So we reviewed one-step inequalities and graphing inequalities. Today we're going to solve multi-step inequalities. Important to remember, it's the same process as multi-step equations. You're going to distribute, you're going to combine like terms. If you have a variable on both sides, you want to move the smaller one, and then you want to solve whatever resulting two-step inequality you have, okay? So this first one, if you'll notice, it's got distributive property, right? So we're going to distribute first. So 4 times x is 4x. 4 times negative 3 is negative 12. We're going to copy the greater than negative 24. Now it's just 2 steps. We're going to add the 12 to both sides. We get 4x is greater than negative 12. Divide both sides by 4. And x is greater than negative 3. So we'll use, some of you used this the other day and it was a good little thing. Put that key number in the center of the number line and then fill in the number line around it. This is greater than, so that's going to be an open circle, and greater than negative 3 is to the right. So that means if we take any number greater than negative 3, negative 2, negative 1, 0, and we multiply or we substitute it in for x, subtract and then multiply, we'll get an answer greater than negative 24. Everything greater than negative 3 makes this inequality true, okay? The next one, you'll notice it has distribution and combining like terms. So we distribute first, so we will copy the x. We'll distribute the negative 3, so negative 3x, and negative 3 times a positive 2 is negative 6. That's greater than 4. Now we have to combine. X minus 3x is negative 2x, minus 6 is greater than 4. We have a two-step inequality here. We'll add 6 to both sides. Negative 2x is greater than 10. We'll divide both sides by what? By what? By what kind of 2? A negative 2. Ding, 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 ding. That means we have to reverse the inequality. So x is going to be less than negative 5. So if we put that negative 5 in the center, fill in our number line around it. It's less than, so that's an open circle. Less than is to the left. Whoops, that should be an 8, shouldn't it? Okay, so everything less than negative 5, if we were to plug in negative 6, negative 7, negative 8 in for x and simplify that, we would get a number greater than 4. All right, let's get a little more complicated. Here we have a variable on both sides of the inequality. Here's your inequality symbol. I don't typically draw the line through that, but if that would be helpful, you can do that. But we have our inequality here. The 6x is on the left, the negative 2x is on the right. We cannot combine them. We have to move one of them. Typically, we have said we will move the smaller one. So I'm going to add 2x to both sides. 6x plus 2x is 8x. 8x plus 1 is less than 9. Now we're to 2 steps, so I'm going to subtract 1 from both sides. 8x is less than 8. Divide both sides by 8, and x is less than 1. If we have to graph it, we set up our number line. 1 less than, open circle to the left, and we have solved and graphed. All right, this next one is about as ugly as it can get, right? We've got a little bit of everything. We've got distributing, we've got combining like terms, we've got variable on both sides. I see a negative in front of parentheses. Lots of things here we've got to pay attention to. Okay, so the first step is to look at both sides of the inequality and distribute. So I've got a 5x. I'm going to distribute a negative 3. So that's minus 3x. And negative 3 times a positive 6 is negative 18. Greater than or equal to 8. Notice that there's a minus sign in front of the parentheses. Remember, that's a negative 1. So I'm going to take this -1. -1 times x is -x. -1 times -7 is +7. Remember that changes the sign of everything in the parentheses. Now, look at both sides. Look at the left. See if there's anything you can combine. Look at the right and see if there's anything you can combine. I see 5x minus 3x. That is 2x minus 18 is greater than or equal to, I see 8 plus 7, which is 15 minus x. Now I have a variable on both sides of the inequality. If you will move the variable before you move any numbers, you will make fewer mistakes, okay? I could move the 18 or the 15, but if you'll move the variable first, you'll save yourself some heartache. So I've got a 2x and a -x. The -x is smaller, so I'm going to add x to both sides, and I get 3x minus 18 is greater than or equal to 15. Yep, you thought I'd messed up, didn't you? I'm going to add 18 to both sides, and I get 3x is greater than or equal to 33. Is that right? Divide both sides by 3, and x is greater than or equal to 11. So I can put 11 in the center of my number line. This is greater than or equal to, so that's a closed circle. Greater than is to the right. Just like with most things in math, there are special cases of inequalities. These are very similar to some special cases we had in solving equations, but we need to talk about what it looks like since it's an inequality, okay? So this first one, 5 times the quantity in m plus 5 is less than 5m plus 17. So I'm going to distribute this 5. I don't have anything to combine. You will notice I have the 5m on both sides, right? So I'm going to subtract that, and that's going to go away. We know when our variable cancels, when it becomes 0, something weird's always going to happen, right? So I end up with 25 is less than 17. True or false? False, right? This is a false statement. And if you get a false statement, that means there is no solution. Just like when we solved equations and we got 2 = 3 or something like that, if you get a false statement, the answer is no solution. And if there's no solution, there is no graph, right? So if you get a false statement, it's no solution, it's no graph, okay? So let's look at the other special case. I've got 1 minus 8s. There's not anything I can do on the left. Is less than or equal to, I get negative 8s and what? A positive 4, right? A -4 times a -1 is positive 4, right? So I've got a negative 8s on both sides, so we know something funky is going to happen. We're going to add 8s to both sides, and I end up with 1 is less than or equal to 4. Well, is that true or false? That's a true statement, right? 1 is always less than or equal to 4. If you get a true statement, that means the solution is all real numbers. Every number on the number line is a solution. We can't really say infinitely many solutions for this because every inequality, except for a no solution, already has an infinite number of solutions, right? X greater than 3 has an infinite number of solutions. So we have to actually say all real numbers. Well, how do we graph all real numbers? The graph of all real numbers is the entire number line. So we draw the number line as far as we can go. We put an arrow on both ends, and that shows us that the whole number line is the graph. The graph of all the real numbers is the whole number line. Don't forget to put your arrows on the end, okay? All right, well, if you have any questions about any of these, let me know, and you are ready to do some practice.